Hello Year 3. For science today we're going to review forces. Name the force acting on the objects. Is it a push or a pull? If we look at the man swimming, he is pulling the other man on the ski. Is this picture a push or a pull? We can see the man is pushing the trolley up the ramp. What is this child doing to his mother? Is he pushing or pulling her dress? That's right, it's a pull. He's pulling her dress back. And what is this lady doing with the stroller? She is giving it a push to make it move forward. Name the action used to change the shape of the objects. Are they a squeeze, twist, bend, stretch, or squash? Let's have a look at the plasticine. You can see it's going in one direction, so it is a squash. What is the effect of the force on the object? It's getting a squash, so we know that it is changing the shape and it's flattening it. After the applied force stops, will the object return to its original shape or stay in the modified shape? We know that if we play with Play-Doh, we squish and twist and bend and flatten it, we know that it will stay in its modified shape. It will stay in the form which we put it in with force. Name the action used to change the shape of this aluminium can. The fingers are going in all different directions, pointing inwards, so it is a squeeze. What is the effect of the force on the aluminium can? When it's being squeezed, we are changing its shape and also we're compressing it, so we change its size. After being squeezed, will the aluminium can return to its original shape? No, it will stay in its modified shape. Name the action used to change the shape of this wet towel. We are turning our hands in opposite directions. One is a push and one is a pull. That means it is a twist action. What is the effect of force on the towel? First of all, when we twist it, we are changing its shape. It is no longer a rectangle. Also, when we twist it, we compress it. So it is going to change its size and become a little bit smaller for a while. What will happen after we stop twisting the towel? Will the towel return to its original shape or stay in a modified shape? The towel can go flat again and return to its original shape. Name the action used to change the shape of this metal bar. The man is pushing it quite hard, and the action is called a bend. What is the effect of the bend? We are just changing the shape of the metal bar. Will this iron bar return to its original shape or stay in the modified shape? After being bent, the metal bar will stay in its modified shape. Name the action used to change the shape of this elastic band. We are pulling in opposite directions, so this is called a stretch. What's the effect of the force on the rubber band? Well, when we stretch it, we change the shape. It starts off round and it becomes longer and oval. We also change the length because when we stretch it, it stretches out and becomes longer. And we also change the size a little bit because it becomes thinner as we stretch it. After the stretch force of this rubber band stops, will the rubber band return to its original shape or stay in its modified shape? Let's think about if we did this ourselves. We stretch a rubber band and then we let it go. How does the rubber band look? Does the rubber band still look stretched or does it return to its original shape? That's right, it returns to its original shape. Which object will need less force to change its shape? The Play-Doh or the elastic band? Well, the elastic band is very thin and very weak, so the elastic band will take less force to change the shape. Will the metal bar or the aluminium can take more force to change its shape? Well, the metal of the aluminium is very thin, so when we squeeze it, it's quite easy to change its shape. But the metal bar is very thick and it will be very difficult to change its shape. So the metal bar will require more force. Look at the two pictures. Does the force needed to move the object increase or decrease? This first picture is a woman with an empty trolley. And then the second picture is a woman with a full trolley. Is there an increase of force or a decrease of force needed? That's right. We need to increase our push force to make the object move. A boy is pushing his brother inside a toy car. His brother gets out of the car. Does the force needed to move the car increase or decrease? With less mass, we now have a decrease of force needed to move the car. We have a man doing push-ups. Then the cat comes and jumps on his back. Does the force needed to do the push-ups increase or decrease? We know that when we have more mass, we have more force. So with the extra cat on his back, we need to increase the force to do the push-ups. Is the force balanced or unbalanced? The blue man on the left pulls with 100 newtons. The child and the man on the right, in red, pull with 150 newtons. Is it balanced? Are the numbers the same? Is the force the same? No, it is not. It is unbalanced. When a force is unbalanced, an object will move or not move. We know that when we have a greater force, the object will move in the direction of the greater force. Therefore, the object will move in the direction of the red people. Is the force here balanced or unbalanced? The boy on the left pushes with 50 newtons. The boy on the right pushes with 50 newtons. Therefore, the force is the same, so it is balanced. When a force is balanced, an object will move or not move. We know that for an object to move, it needs to have a greater force in one direction. But here, we have equal forces. Therefore, the object will not move. Is the force balanced or unbalanced? We have two women pushing a box, both pushing with 100 newtons each. Because there is no push force going in the opposite direction, we know that it is unbalanced. Because we have the direction of the greater force all going towards the right, we know that when a force is unbalanced, an object will move. Here we have two forces on a seesaw. On the left, the force is 50 newtons. On the right, the force is 100 newtons. Is the force balanced or unbalanced? That's right, it's unbalanced because 100 newtons is the greater force. So, do you think the seesaw will move? That's right. We have a greater force on the right side. So that means when this force is unbalanced, the seesaw will move. Is friction useful or a problem when we are sliding down a slide? Well, friction is a problem because friction will cause us to slow down and stop. We will not be able to slide easily with too much friction. Definitely a problem. Is friction useful or a problem when holding a vase of flowers? We know without friction, the glass will slip and fall out of our hands. We need friction to grip and hold objects. Therefore, friction is useful. What about wear and tear on car tires? We can see on the picture on the left, the car tire has lots of tread, it's brand new, which means we have some grip, we have some friction. The car tire on the right has been worn down and now it's very smooth. We know that friction wears down and makes the tire surface slippery over time. Worn, smooth tires are slippery and dangerous to drive with. Therefore, for wear and tear, friction is a problem. What is the correct direction of friction? On the left, we can see the direction of motion and the direction of friction is opposite. And on the right, direction of motion and direction of friction are in the same way. We need to remember, friction opposes motion. It goes the opposite way. Therefore, the one on the left with the arrows going the opposite way is the correct direction of friction. Which surface will have the least friction? A sandy beach or a bedsheet? We know that sand is rough and bedsheets are smooth, so the bedsheet will have the least friction. Will the sandpaper or the drawing paper have the most friction? We know that drawing paper is smooth and sandpaper is rough. Therefore, the rougher the surface, the more the friction. So the sandpaper has the most friction. Which surface will have the least friction? The rocky footpath or the ceramic floor tiles? We know that when we walk over both of these, the rocky footpath definitely has a lot of friction, a lot of grip, and the ceramic floor tiles can be slippery. So we know the least friction is on the ceramic floor tiles. A girl is sliding across ice on one ice skate. Now the question is, will friction make the girl speed up or slow down? We know that friction opposes motion. So that means over time, the girl will start to slow down. A bowling ball is rolling down the lane. Will friction make the ball speed up or slow down? We know that after the initial push, we have friction going in the opposite direction. Even on a slippery surface, friction will always make an object slow down. Which object has the greatest force? The cup has 3.2 newtons of pulling force, the teddy has 4.1, and the toy plane has 2.4 newtons of pulling force. We can see the greatest force is the greatest number, the biggest number. Therefore, the teddy has the greatest force. Put the results into a table. First, we add the cup. We write 3.2. Next, we write the teddy, 4.1. And then we write the toy plane, 2.4 newtons. Which equipment do we use to measure how much force is acting on an object? Is it a balance, a ruler, or a force meter? Which is the correct equipment? We can see in the question we are measuring force. Therefore, we should use a force meter. That's all for today, Year 3. Thank you, and we'll see you next time.